squared ought to be 0.923. That first one. Okay. I would use just 2 decimals on stuff. 2 decimals would be fine. Now, it's going to ask a question about the mean absolute deviation. So remember what we did? I just wiped out that leverage column, because we never use it. And I said abs residual. So it's going to be equal abs. And then point and click on the first residual. Now, I can't promise yours would wind up in D24. And just copy it down and average them up. And that's going to be your mad value. Okay, let's look up Durbin-Watson. I'll help you with that. Okay? This Durbin-Watson is 1.27. My sample size is 32. He's not real close to 2, is he? Okay? So let's go out to the Durbin-Watson table. Bring it back. Okay, so the closest number to 32 is 30. That's your sample size in observations. I've got 1 predictor time. So as long as Durbin-Watson is greater than 1.35, we're happy. And all we do is say there is autocorrelation or there's not autocorrelation. So as long as RDW is under 1.35, it's good. Okay. Then it helps me, like I said, to go back and look at that data. This was 2012. So these next time periods will be in 2013. So this would represent quarter 1, 2, 3, and 4. For the predicted values there. Quarter 1, 2, 3, and 4, 2013. And then I realized, ooh, look at that. I have a pattern. I have a big pattern over and over and over again. All right. And again, if we had a bad outlier, you just tell me, yes, there was, or no, there weren't any outliers. Okay, and here's R squared. It's on the plot there too. So you get R squared at the top on the plot. Now, next set of instructions. So that's the first set you need. Next set, de-seasonalize the data. De-seasonalize it. So we're going to just say megastat, time series, and then de-seasonalization. Okay. And so that's in C1 through C33. It's quarterly. And I'm going to say start in 2005. Okay. Don't let all this scare you. Ignore it. We need 2 things. We need adjusted seasonal indices. So I need those guys. And then I always just pull this equation up to the top. I just drag it and drop it up here. Now here's what you need. I would go ahead and create a T column. And see, the last time period was 32. So then we're going to live through 33, 34, 35, 36 in 2013. the predicted or secular trend. That's your equation. Okay, so the predicted part is right here. You're going to plug in to this one. So again, don't copy the cell reference, but it will look like this. 884.68 times, and then you point to where 33 is, and then plus 3,727.1. And that way you just copy it down. So that cell location just represents the next time period, 33. So just copy that down, and then get the adjusted seasonal indexes. Just type those over, or you can copy them either way. You have to use transpose to copy them. So those guys are given. Then, again, on your formula sheet, forecast is going to say predicted times adjusted seasonal index. So you're just going to multiply straight across. Predicted times adjusted. And that's it. And copy it down. Okay, note what R squared is. That's going to be one of the things we want to look at. So back over here, let me make sure I've covered everything we need to know. So in the first part, we did a linear trend line, and that equation is right there under coefficients. That's where you find your equation. R squared, standard errors at the top. We'll look for outliers under student type, residuals. Find the mean absolute deviation. We did that part, okay? Look at Durbin-Watson, okay? So the critical value within a 30 was 1.35. As long as our Durbin-Watson is bigger than that, there's no autocorrelation. So this is your critical value. Upper limit 1.49, we don't care. If it's bigger than that, it's okay. All right, then time, is it a good predictor? Look at the p-value. And on average, how much does it change per year? That's your slope. And then we predict it. Then here's our deseasonalized stuff. Secular trend, that's the equation on the plot. R squared, predicted values, we just did that with the straight line. Average rate of change, again, that's going to be the slope. And then forecast. So whatever adjusted seasonal index is largest, that's your best quarter. Over one's good, under one, we're less than average. So that's the first half, okay? Next half, we're going to use the Time Warner data. So I'm going to go back to Excel to the data. So here's Time Warner. Okay. All right, it says do time series moving average 3 points. So it's that simple. Megastat, time series, moving average, and highlight the data and put in a 3. So this had been like a 1. And this had been blank. So I highlight the data, put in a 3, the 3 point, and click OK. So whatever that last value is, that's your best estimate for the next year. The best estimate for the next year is that last moving average. Okay, then we're going to try exponential smoothing. Okay. If I insert that command is going to be add-ins. There we go. Add-ins, megastat, time series, exponential smoothing. Simple. And again, I just highlight where Time Warner is in C36 through C52. Alpha, you know, it may have been 0. We're going to make it 0.7 and leave the other stuff blank. So you just highlight those, put 0.7 for alpha, and click OK. And look at this, I love exponential smoothing because it just spells it all out. Our forecast for the next time period is right here. See, this would be year 16, whatever that corresponds to. So the next year would be COVID 17. And there's our forecast right there for us. All right, and then finally, we're going to do an exponential log. Okay, so this is just like the last one on the handout that we just did. So you'll say add-ins, megastat, trend line, under time series trend line, and then we'll tell it, here's the data, here's the data, and then it's exponential log. And then we start with time period 1, forecast, what did I tell you the forecast for? 2 time periods, starting in 17. And then we get all these guys like we've done later. All right, so here's R squared up here at the top. Now here's the important part. You want to use this middle part to answer questions about the equation and the average rate of change. That's the important area right there. If we look for outliers, are there any? No. Okay. And then to predict, we don't want